Welcome, Trig students. We are on lesson 49. This lesson is all about logarithms and the rules. You can follow along on page 338 in your textbook. You will need to have that out soon, but I'll start off by saying the text does not give you all these rules written out. So they're nicely written here in your notes. You're not going to need to memorize them, but you are going to need to know how they apply. So we're going to start off just utilizing these rules down here with questions 1 and 2 and 3. We're not using a calculator, but instead we're going to use the rules of logs to simplify each of these questions. And I recognize there's not a lot of room next to those, so I'm going to go ahead and write question 1 up here and copy down what A is. A reads log base 10 of 1,000. And we're going to figure out how we simplify that without a calculator. So you'll first focus in on what's the log portion. And we're going to rewrite 1,000, the log portion, as it is a base of 10. Okay, so I have log base 10, but I want you to think in your head, 1,000 is 10 raised to what value? And that would be 10 to the third. There are 3 zeros, and the tens trick says that would be 10 to the third. Okay, then after you've done that, you're going to go to what is rule 3 on your notes. You're going to take that 3 value, the exponent, and you're going to bring it out front and rewrite it as it's out front. Now that it's out front, what I'm left with is a log base and a log that are the same. And we have log base 10 of 10. When they are identical, it simplifies to 1. Okay, that's rule 5 over on the left side. So log base 10 of 10 simplifies to 1 because the 10 and 10 are identical. In other words, this whole thing simplifies to 3. And that is my solution. All right, we're going to do that same method for question B. Question B is to do log base 4 of 16. So I look at the log and the base, and I need to write 16, rewrite it with a base 4. So rewritten, 16 is 4 squared. Then I use the exponent rule to bring that 2 out into the front. So now I have 2 log base 4 of 4. Notice that my base and my log are the same. So that means this can simplify to 1. And that exponent out front is still the solution then, which is 2. Okay, going to question C. One C has log base 2 of 64. And what we'll do first is figure out 64 rewritten as a base of 2. Okay, so 2 to what power equals 64, and that is the 6th power. Then we bring that 6 out front, the exponent rule. We're left with log base 2 of 2, which is going to simplify to a 1, so my solution is 6. All right. The next method I'm going to use for question D. For those of you who are a little more mental or would like a shortcut, log base 3 of 27. I want to think in my head 3 to what power equals 27. That's mentally in my head. I'm thinking 3 to what power is 27? And the answer would be 3, and that's the solution. Okay, so I could If I look back at question A, I could have answered the same thing. I could have said 10 to what power equals 1,000. Or on question B, I could have said 4 to what power equals 16 and gotten the same solution. So just some shortcuts for those who are able to follow along with that. Now that I know those shortcuts, I go to question E. Log base 9 of 81. So 9 to what power equals 81? And that would be 2. All right, and then looking at question F, I have log base E of E squared. And it doesn't matter if I know what the value of E is. I'm going to think of it as that 2 coming out front because it's an exponent, and log base E of E canceling. So my solution is just 2. All right, then I'm going to go to the question 2 and try a different style of problems. So question 2, A, log base 10 of x equals 5. How we're going to solve this is we have to rewrite the log in exponential form. Now that is a lesson that we've already learned, but let me refresh your memory. You start with the base, and you make that the new base. Raise it to the answer. 10 raised to the answer, which is 5, equals the log x. So 10 to the 5th equals x. So I rewrote it in exponential form, and now I can just simply solve what is 10 to the 5th. That means 1 followed by 5 zeros, or 100,000. Okay, when I go to question 2b, log base 2, y equals 5. Remember that we do base raised to answer equals log. So base raised to the answer equals the log. So 2 to the 5th equals y. You need to calculate what 2 to the 5th is, and you should get 32. Okay, and then question C. Log base 3 of z equals 4. Rewrite this as base raised to the answer equals log. So base raised to the answer equals the log z. So z is equal to 3 to the 4th power. That means z is equal to 81. All right, so those are utilizing the rules that were given up above. We are going to have to do some of question 3 because these are a little bit trickier. So I'll just scooch over to a different section here to fit it in. And we're going to skip around a little bit. I think question A is obvious. We learned base 10 of 10 means that whole thing is equal to 1. But I need to go over question B. Log base 4 of 1. If I were to rewrite this in exponential form, I have to add a variable over here. So let's just add an x over here. And rewrite it base raised to the answer equals 1. Well, any way that I can raise something to a power and equal 1, the only way I can do that really is to have a power of 0 in order to equal 1. So x equals 1. So in this case, I wouldn't say x because I just created that for that solution. but I would say it simplifies to 1. Log base 4 of 1 simplifies to 1. That's going to be true for question E, okay, because it has that same setup. We can take a look at, let's skip over to question D. This is 3. Question D, oops, it is log base 2 of 0.25. And we're going to change that decimal to a fraction. So log base 2, rewrite it as 1/4. So in your head, you need to think 2 to what power is equal to 1/4. And hopefully your mental math skills will help you there to find that would have to equal -2. 2 to the -2 power is equal to 1/4. Okay, so that gives you some good examples to try from. We're not doing all of them. We still have more on the next page that we're going to get through. So going to the next page, go to question 4. And now we're going to get into what's called the multiplication and division rules. It looks like we're adding and subtracting, but in log world, that is really multiplying and dividing. Okay, so I'm going to focus in on question A. First of all, I have to make sure they have the same base, and they do. They both have base B. So then I'd see that it is a subtraction, and back on the original page of your rules, you're going to see this is actually rule 2 that has subtraction can be rewritten together as a division. Okay, so coming back over here to question 4, I can combine these into the same log base B and make it 8 divided by 2. Okay, and then I need to simplify that one more step. So log base B of 4. And that is where I stop. I can't do any more simplifying of it. Question B is just a little bit trickier. I see that I have a number out front. So that's the exponent rule. When there's a number out front, it can be rewritten as an exponent. That's going to be the first thing I do. So I'll rewrite question B, log base B, 3 squared, plus log base B, 2. Okay, and then the next thing is to address the addition. That is actually a multiplication rule from the first page. So I take away the addition sign, I combine these into a multiplication of 3 squared times 2. Okay, that's this 2. And then I'll simplify that. Log base B, 3 squared is 9 times the 2 is 18. So log base B of 18. Okay, and we'll do one more. Question C is a little tricky because it starts out actually as a 1 minus log base 10 of 4. So I have to rewrite a 1 using logs. And we learned already if I use the same base as I do the log, it's equivalent to 1. So I want to use a base 10. Rewritten, it would be log base 10 of 10. Okay, that's equal to 1. Minus log base 10 of 4. I just bring that straight down. Now I have both of them written in log base 10. So I can combine them. And with a minus in between, it means I'm going to divide them. So I have log base 10, 10 over 4. And you just need to simplify that. 10 over 4, it can be rewritten as 5 over 2. Okay. And there is a proof Saxon gets into here. We're actually going to skip that proof for now. because it kind of goes into it on question 8. So let's skip over to your homework, question 8. And this says, let m equal b to the a, let n equal b to the c, and then show, or in other words, show a proof of how this log rule of multiplication and addition comes about. So I'm going to start by writing the rules that were given, or the statements that were given. We were shown that m is equal to b over a, and also n, Nancy, is equal to b over b to the c. Then I'm going to take each of those statements and rewrite them in log form. Okay, we've gone back and forth with this. If I go from log form to exponential, or exponential to log form, I always start with the base. So in the exponent, this is the base. And so when I go to rewrite the log, I put that base down there first. And then I'm going to split it. The a is the answer, so it's actually going to have an m here, and I split the a to the other side of the equal sign. Okay, I'll do the same thing over here. I start with the base of the exponent, and that's b, so that's the base of the log. And then it's the splitting of the answer, so n equals c. Okay, from here, I'm going to make a statement about my original m times n. Okay, so m times n is the same thing as b to the a times b to the c. That's just using substitution. Okay, and then I know from my algebra principles that if I have the same base, I can add my exponents when it's being multiplied. So I would have b raised to the a plus c. Right? And then if I took a log base b of both sides, applied log base b to both sides here, I would be left with this statement. And on the right side, you should note those two are going to cancel out that log. Okay, so I am left with log base b mn equals a plus c. Okay, and then from the beginning we learned a and c, and we'll use substitution. So log base b of mn is equal to log base b of m plus log base b of n. Okay, and that's just using the substitution up here. And that's it. There isn't really a solution, it's just more or less showing a proof. Okay, and I'm going to give one more question of help here, and that's from question 4. Question 4 reads, Rob can do 2 jobs in 3 days. Beret can do 5 jobs in 6 days. Rob works for 3 days, and then Beret begins to help. How many days will it take to complete a total of 74 jobs? So I'm going to write down what I learned, Rob's rate, and yes, I kind of shortened his name. He can do 2 jobs, and it takes him 3 days. And his friend, Beret, does 5 jobs every 6 days. Okay, and then we're going to set up kind of a general outline of this. we're going to have the rate of Rob times the time of Rob. And we're going to add that to the rate of Beret times the time of Beret. That'll give us our total jobs. Okay, so the rate of Rob is 2/3. And sorry about that, iPad glitch. We'll come back and talk about his time. The rate of Beret is 5/6. And we'll also come back and talk about his time. The number of jobs total that we want to have done is 74. All right, so going back to look at the time now for each of them. Since Rob worked for 3 days before Beret started, it's actually going to show that he did 3 plus their combined days, which I'll call D. And Beret only did D days. From here, I could distribute. I could also do elimination or eliminating the fraction. If you guys remember, by finding the LCD, in this case it's 6, and multiplying times 6 outside these 3 components, that's going to wipe out some fractions, so I just don't even have to mess with it. You can keep the fractions and go that route if you'd like. In this case, the 6 and the 3 would reduce, and I have 2 times the 2 that's already there, and then 3 plus D, plus the 6 cancels, and I just have 5D equals, and then 60 or 6 times 74, which would be 444. Okay, and then I'm going to go back and distribute. 2 times 2 is really 4. And 4 gets distributed across, so that would be 12 plus 4D plus 5D equals 444. Simplify, I get 9D equals 432. And that should go in that perfectly. 48. Now we're asked, if we go back and check question 4, how many days will it take to complete a total of 74 jobs? Well, it took 48 days with them together, but remember that was also 3 additional days that happened prior that were just Rob's days. So that makes the total 51 days. All right, that's it for our lesson today.